Thank you, everyone, for joining. Really excited to share today. Before we jump into things, just wanted to give a quick overview and introduction. We are Logic 2020 technology and business consulting company. We specialize in supporting technology efforts in a lot of different ways, and today we'll walk through how that's been realized in image analytics. And how that can apply to utility transformations, as we've seen with some of our clients. So really excited to share what we have today. Before we jump into it, some brief intros. I'm Adam Corneal, Senior Director of Advanced Analytics. I've got with me today Alex Johnson, Architect of Machine Learning, and Syed Ali, Manager of Grid Operations. And we're going to share some details here that should be a bit fun. If you would, please go to the next. We'll walk through some of the drivers of image analytics, what's making this happen, and what's possible. We'll walk through a case study of one of our clients and how imagery has really transformed how they operate. And then we'll give a few more examples of other use cases for imagery. How it's been helpful and what you can do with it. And then walk through what it looks like to put that into practice, how to set a roadmap, what are some of the fundamental pillars, and what do you need to have in place in order to use imagery effectively for operations. So excited to jump into it. If you could go to the next slide, please. So before we do, just a quick level set on what we're talking about here. When we talk about imagery, we're talking about everything across the spectrum here: LiDAR, satellite imagery, drone imagery, ground-based capture. There's a lot of new technologies at our disposal, and they're getting cheaper and easier to deploy. More ways to capture situational awareness of the field. So be that images of assets, vegetation, more topographical information. There's just so much available. And so what we're going to talk about today is how you take that and put that into action and do transformative things with it. So excited to share. As I said, I'll jump into an example here. This is just a brief example of one of our clients that we've worked with for a few years. And help build from the ground up a drone-based imagery program. So they've integrated drones into their inspections process. So we've got millions of images pouring in of transmission assets out in the field. And we saw that as a huge opportunity. So we've built machine learning models that take that imagery and isolate the different components out in the field. So you can see, as an example there, an insulator being picked out. Next, another model layers on top of that and picks out what material that insulator is made out of, if there is potential damage on that insulator. And we have this happening across many different asset types. So really exciting, and hopefully you can start to see the potential right away that when you've got this imagery and this machine learning together, you can start to automatically detect what's out there in the field and provide more intelligence. We weave this into the inspections process to provide hints and checks against inspections so that everything is caught and cataloged, but also to speed up the inspections process, pre-populating some of the forms that inspectors would otherwise be filling out, and improving the quality of the catalog of assets out in the field. Altogether, that is a massive improvement. So, not even quantifying the improvements to reliability and safety, this means that there's a more comprehensive catalog of assets for making decisions and planning, that we're saving tons of time for inspectors and ultimately saving lots of money by doing it. So that's just one example of what it looks like to put imagery into practice. As I said, there's many. And so I'm going to turn it over to Syed to walk us through a few of the other use cases.
Thank you, Adam. So yes, talking about use cases, as you can see on the left-hand side of your slide, we're going to start off with the approach. Here I have divided use cases into three main buckets. Again, this is a non-exhaustive list, and you can mix and match depending on the use cases and needs and the underlying issues of your particular need and your utility. So inspection, circuit flights, annual, quarterly inspection, post-storm inspection is something that every utility does. We have circuit sweeps and asset management. Uh, a mid-sized utility has a couple of thousand miles of distribution and transmission lines at least, and they would want to make sure that they are in their prime condition or as much as possible. Also, as well documentation, because we know GIS is a legacy issue at various utilities, and we want that to be most up to date. And you can use image analytics to make sure that your database is up to date there. And finally, planning and design. When we talk about gas, pipeline infrastructure or even transmission lines, we're talking about that construction spanning over miles. And if you want to have a good snapshot, or if you want to understand what is going to be like the feasibility of this project, what are the topography we're going to be going over, it is a very good tool for you to make sure that everything falls in place and the project you're embarking on is going to flow smoothly. On the right, since I'm guessing, we have a few C-suite folks here on the call with us, and they would like to know that if I spend, even for a pilot project, if I spend X amount of dollars for any of these buckets, or even for one use case, what is going to be the impact or the rate of return or return on their investment? So I have again divided impact into three buckets: safety and reliability. This is to avoid the downtime with making sure the asset is healthy and the CDKD numbers are reflecting that. Secondly, on-site visits. Now again, as I mentioned, because we are inspecting lines which are going through different terrain, it could be hills, it could be waterways, it could be other things, and we want to make sure that our personnel are away from harm's way, and that's why safety plays a big role here. Cost effectiveness, so efficiency and cost effectiveness goes hand in hand. We want to reduce the truck rolls. We want to make sure that one device, for example in this case drones or even satellite, is being able to capture a large amount of area in reduced amount of time, and therefore you will get an improved inspection quality. Finally, compliance, because utilities, whether gas, electric, they fall, they are compliant, and they are under a regulated industry, and they have to be responsible for their not just ratepayers but also to the PUC body as well. So this use case and the way you will be capturing something and then inspecting and finally mitigating that risk, because it will cost you, and you want to make sure that you get compensated for that, or you are getting the return. You have to show that in the filings, and this images and this entire process will really help you in gathering that information. So with that, if you move on to the next slide, you will see, this is a snapshot of what it's going to look like in the long term. As you can see, we have different levels, and this is a maturity model. From if you want to start from very basic and you want to get to that level where most of the things are automated. For the sake of this webinar, we're going to assume that we are an electric utility and we are on level 2 of our maturity model. And I'll quickly go through each level to make you understand what exactly it is. So level 1 is a very initial stage where most of the effort is manual. You have personnel going out in the field and manually inspecting poles, lines, and everything, maybe using a mobile phone to capture images and then bring them back and trying to figure out how exactly their assets are. And then level 2 is different departments on their own, from their own budget, have started grabbing onesie twosies drones. They have a drone pilot who is going out not periodically but just scarcely, and then capturing images to whatever they need it for an upcoming project or something, and they're collecting images. But now finally you are seeing the manual effort being decreased, and the automation increasing, because now there is a device, a service in play, could be satellite imaging, could be drone or LiDAR. So that really reduces the manual efforts and start increasing the automation. Eventually, you want to get to level 5. Now, what is level 5? That's where you will use AI and ML and fixed wing, drone in a box technology, which will have a set flight path. And, periodically, whether it's every month or every quarter, they will, get out of that box. The drone will capture the imagery, or the satellite will download, capture the latest imagery and download into the system. And then the AI and ML will help, run that model and try to understand, for example, vegetation growth. Previously done, last month or last quarter, this was the amount of growth. And then with comparison to the latest imagery, they can exactly calculate how long is it for your next trimming cycle. This will really help you be more cost effective and be efficient in your trimming cycles, in avoiding outages and everything. Though there still be some manual effort required. For example, the final result will be understood and then be addressed by somebody who has knowledge of this. And once the AI/ML spits out the results, it will be a person from the utility who will then finally make a decision on where do they need to finally attend or spend their efforts to. So this was just a snapshot of how eventually this will look. Again, this is not cannot be achieved overnight. There's going to be a roadmap, 4 years, 6 years, depending on each utility's path and plans. And eventually, this can be achieved and will be achieved by most of the utilities in near future. With that, I will hand it over to Alex to take you to the end of this presentation.
Thank you, Syed. And so embarking on a computer vision program and building that competency is a really broad task. And there's many different work streams that work together to help achieve this value. So starting at square one, we start with program strategy. And so making sure that we're building that focus on strategic management to identify and leverage high value opportunities effectively. And then making sure that we're guiding from concept to deployment with a clear incremental roadmap that ensure those tangible benefits. And then moving around the circle, we go into data labeling. And so how do we leverage our SMEs, so electrical engineers, our domain experts, and our data scientists to develop advanced labeling processes and define a workflow, and then making sure that we're enhancing machine learning model performance through high quality tailored labeling, while taking advantage of these SME expertise, So what we see here is often the highest ROI and an important element to get right in terms of building a program. Then we move into image capture, where we're prioritizing high quality data capture and storage to make sure that we're supporting accurate asset monitoring and predictive maintenance, and utilize advanced imaging techniques that are essential for reliable data analytics and application as well. And then integrations and machine learning engineering. So how do we integrate them into our existing tools? And can we seamlessly integrate our ML products with our current systems to deliver essential data to key stakeholders effectively? So you can think about maybe integrating this into a work order system, maybe Maximo, and really enhance the decision-making and operational responsiveness through that real-time data provision and automation, and DevOps and automation really fuel this engine and allow rapid deployment and integration as well. And then building that data science expertise. And so do we have data science programs established? Are we adhering to data science best practices, taking advantage of the latest tools and methodologies for optimal model accuracy and utility? So the field changes pretty quickly. Do we have teams that have the skills necessary to help push this forward and develop precise, scalable models that really improve prediction and analysis, as well as the optimization of operations in a really measurable way, because we want to be able to showcase this value of this investment. And then lastly, building out that data science platform and product. Do we have a robust platform that can really facilitate large-scale data processing, as well as easy to access images and metadata? So oftentimes we see our clients moving to the cloud for this and making larger investments in that commodity infrastructure, and ensuring that the infrastructure can support both the computer vision model accuracy and operational efficiency in order to process these images at scale, because usually it's high volume. And so as we're going through these, there's elements of the buy versus build decision. And it's not necessarily about just adopting new technology. It's about really transforming the operational landscape to be more data-driven and more efficient. And so by focusing on these foundational elements, we can ensure that our investment in image analytics yield those substantial and measurable returns. Next slide. So it sounds like a big problem, but you don't have to solve it all at once. And so given that complexity that we outlined, we generally recommend 3 focus areas, and this is where we found some success in the space. So building these 3 more bite-sized chunks as focus efforts to really prove the concept is there, prove the value, and be able to showcase this to leadership. And so the first things first, starting with program strategy, establishing that use case identification and strategy. And so conducting that thorough analysis of pinpoint key use cases and identifying where technology can resolve specific operational challenges and do so effectively. And so this really allows us to tailor our solutions to meet those exact utility needs, enhancing both our efficiency and our impact. No 2 utilities are solving the same kinds of problems, but there are a lot of similarities. And so making sure that we're taking that honest assessment of what matters to us and our territory, and how can we take steps to address those as well. And then we're talking about technical products. And so a big element of that is establishing that IT strategy. And so we need to partner with IT the whole way and design these robust architectures that can support that extensive data platform needs and focus on that computational power and that data storage to really ensure that solid foundation for analytics capabilities and that future scalability. And oftentimes, this is a competency that needs to be developed. Oftentimes, this becomes new territory. And so how can we partner with IT and help them set the strategy to meet those needs? And then also enhance our vendor collaboration. It's really difficult to do this alone. And there's lots of vendors in the space. And so how do we make sure that we actively seek and partner with these industry-leading vendors to enhance capabilities in data acquisition, storage, and processing? There's different elements that you'd want to go out and buy and certain elements that you want to build internally. So thinking about the prior slide, where are those lines for your organization and appetite for investment, and how can we capitalize on that? And these collaborations are really crucial for expanding our technological reach and innovating beyond our current limits and what's possible in our current organization. Moving into the second case is that investment in labeling. I mentioned on the prior slide that this often is where we see the highest ROI, but making sure that if we have a key use case that's identified, where quality data is available and allows us to focus our efforts where they're most needed and where a clear business problem is defined, then it's ripe for developing a pilot, developing a proof of concept to really showcase that value and getting labeled data in our data systems. And so with that, we developed labeling playbooks. So making sure that they're comprehensive enough that we can dictate best practices and detailed policy for how to label data effectively for computer vision tasks. And that's often easier said than done. Once you scale labeling tasks for machine learning beyond one individual labeler, and then becomes paramount importance to document those processes, document those edge cases, because oftentimes there are edge cases. So how can we manage that effectively and make sure that we communicate, hey, this is our clearly defined business problem, these are all the edge cases, and address those and iterate effectively on that as we better define our task. And then with that is providing those feedback loops where we have streamlined, measurable elements where we can highlight the incremental value of our labeled data and ensure that a continuous improvement in data quality. Then from there, it dovetails nicely into a proof of value modeling. So similar before, where we have a well-defined use case and develop those starter models where we create these accessible starter models for those key use cases. And it enables us to quickly demonstrate the potential and effectiveness of image analytics in real utility operations. We've seen a lot of groups do this internally of some kind of Shark Tank process, and being able to just develop quick POCs that then lead us down the road for improved value with those models, and building that model roadmap. So making sure that we're setting a clear roadmap for model development and outlining a progression from these simple starter models to that more complex system that we want to integrate this into. And then that roadmap is making sure that roadmap is aligned with business objectives, ensuring that scalability and it meets the performance goals. So overall, image analytics is a big problem. There's lots of nuance to it, but it is a problem worth solving. As I had mentioned, that this is going to be a journey that most utilities will have to face with the way that they manage assets and infrastructure. And we're really at a point in time in a field that is ripe for opportunity and providing value for the sake of shareholders, customers, and our community. So with that, I appreciate everyone for joining, and I can open up the floor to questions.
And it looks like we have a few. I'm going to open it up to our moderator here. Let me see. Okay, so we've got a question here. What questions should you ask when evaluating new image analytics platforms? Alex, I'm going to turn that one over to you.
Oh, yeah, that's a good one. So deciding on an image analytics platform, as I mentioned, each utility is unique. And so how clearly can we define our business need and our associated technological need that's associated with that? Then also making the decision to build our own versus integrating and what pillars we do. We often see utilities that have those established data science practices and programs, but they have some issues with deployment. So they want to build their own models. And so when you're looking at platforms, when you're looking at these tools, think about, do you want to use some of the off-the-shelf models or build your own, and does that software support that? And some utilities really have some strong opinions on this. Like we're a lot of us are data folks and really want a lot of ownership over our assets. And then also, can it integrate with our existing tools and can it scale to what we need? Oftentimes, these are very compute heavy practices, often using GPUs. Can it support that? And do we get the and also associated costs, of course, and expected return on investment. Also thinking about who owns the IP for our own assets. Oftentimes with some of these software vendors, there's some gray areas there. And then making sure you're answering that question, buy versus build. What do we want to buy versus what do we want to build to help build that more robust program?
Very good. So the next question, I guess, touches on that a little bit. What are the most common challenges with integration for imagery? So I'll speak to that a bit. I think they come in a couple of forms, some technical and non-technical. From a technical perspective, there's some of the things, Alex, you just touched on in regards to running these kinds of workloads. It's very advantageous to have the ability to run in the cloud, to have access to GPUs. If that's not something that's well ironed out in your IT organization, then there are integration challenges there. Even if it is, there may be integration challenges there in order to tie together data from all the different systems that you want to bring to bear. So tying your imagery to your asset records, your GIS information, your work orders, all those systems together, that's a non-trivial technical integration that needs to happen. And there are interesting trade-offs there. To your point also, Alex, about buy versus build. There are some services out there that provide some out-of-the-box integration points with certain services. So depending on what you're working with, systematically, your mileage will vary a little bit, but some of those problems can be a little bit more easily solved than others. It bears planning. But I think there's also a really interesting challenge in people and processes with all of this. So at the end of the day, we're talking about taking new information, this imagery in various forms, and using it to influence decisions and operations that you already run. That means we are changing the way that people work. And we are changing the way that people work in a way that is, in some cases, if we're touching inspections, very deep into how they operate in the field and how you manage your infrastructure. There may be regulatory aspects to that or legal aspects to that. All of this has to be planned out. So it's very important. And in my experience, you can be very successful in bringing this new information about risk and asset intelligence into the field and create a lot of savings and better decisions through that. You have to work side by side with those teams that you're impacting from the beginning to make sure that you're designing something that can be used and is fit to how they want to use it and make decisions and how they understand it. And so I think it's very important to think that through, make that part of your planning process. Syed touched on, sort of the program strategy of how you line up different use cases. So a different kind of integration problem to be sure, but a significant one, I think. I've got another question here that we can address. So, how can you assess the ROI of image analytics? I think Syed, I'm going to turn that one to you.
Sure, yeah, happy to take that. Unfortunately, there's no one answer. I cannot tell you, your ROI is going to be 5% or 10%. It's not easy to quantify in terms of like dollar value, but I think I briefly touched in one of the slides I presented. The ROI is from the metrics that you are going to be focusing on, that particular utilities focus on. So you will see your SAIDI-KD numbers go up. You will see increase in your safety metrics. You can see, some more improvements in your regulatory filings, and efficiency is another thing, that will be improved. So those are the things, where you will be seeing an ROI. And again, you need to run first a pilot program in order to, kind of like for a proof of concept. And that's going to give you the real confidence in scalability and expansion of that program. But yeah, that's the gist of it, that you will be seeing that ROI in terms of some sort of metric improvement.
Thank you. So all right, I think that's all the questions we've got in chat. Thank you everyone for joining. This is recorded, and so we'll be able to share afterwards. Really happy to be able to share the insights and get the good questions. Thank you all. Have a great day.